airplane mode.
Hello and welcome to your briefing. The following video is to help you get to know your new aircraft. Here is some helpful information about the aircraft. It weighs 7 kilograms, its neutral point is at around 50% Mach. The default center of mass position is at 35% Mach. The maximum control deflection is limited to plus or minus 15 degrees, and the maximum thrust is 30 newtons. This clip shows basic controls. When the control surfaces are displaced with yaw, roll, and pitch, the response is consistent with flight dynamics conventions and aerodynamic fundamentals. Before takeoff, it is important to consider ground controls. This clip shows the control available at different speeds. Here you can see that at low ground velocities, the handling is very difficult. At higher velocities, the handling is much better, but at the very high speed, the handling is impossible and the aircraft crashes. Now for takeoff, the unstick speed is the velocity needed for the wheels to leave the ground. As you can see in this video, the flaps are fully down. This reduces the unstick speed as the flaps create more lift, so the aircraft takes off sooner and climbs steeply. Now for the flight controls in this clip. The freestream velocity is at Vmax at 27 meters per second, and as you can see, when the pitch is moved up or down, the pitch angle oscillates and then returns to steady flight. Now the center of mass has been moved backwards to 0.05 meters behind the wing. As you can see, this made the oscillations bigger, so this change made the aircraft more unstable. Now, the center of mass position has not changed, but the freestream velocity has changed to Vstall at 10.5 meters per second. This did not have much change on the handling, as you can see from the similar oscillations. For this clip, the velocity has not changed, but the center of mass has been moved back to 0.1 meters behind the wing. As you can see, the aircraft stall immediately and is terrible handling. Finally, when the center of mass is moved back to 0.15 meters, the aircraft is impossible to control and goes insane. Here is a clip of a roll rate test. The ailerons are set at opposite angles to create roll. As expected, this clip shows the roll rate at a high freestream velocity. As you can see, the aircraft rotates very quickly. Here, the ailerons are set to the same angle, but the freestream velocity is much slower. Set to 10 meters per second, this means the aircraft rolls much slower. Finally, here is a test where the yawing is changed. As you can see below, when the angle is changed, there are large yaw angle oscillations. As you can see, it takes a long time for the oscillation to stop and for the aircraft to return to steady flight. This shows that the yaw damping is much weaker than the pitch damping, shown in previous clips. Thanks for watching.